Okay, this video has an assortment of wave problems showing you how to solve for speed, for frequency, wavelength, and time period. It goes with the worksheet that's shown here, wave problems. It's found in your packet, and we did some of these in class, so it's not going to have every last problem here, but just a few. So here we go. Stereo loudspeakers are often rated to reproduce frequencies anywhere from 20 to 20,000 hertz. So this problem is asking you to find the wavelength for each of the frequencies and that can be found in a loudspeaker. You're going to assume that sound travels at 340 meters per second, so that's your velocity. So let's go ahead and take a look at the equation. We have velocity is frequency times wavelength. If I want to know the wavelength of something, I need to get wavelength by itself, so I'm going to divide by frequency on both sides. Cancel, cancel. And I end up with wavelength is velocity over frequency. So I can go ahead and plug in my numbers there, 340 meters per second divided by 20 hertz. And remember that a hertz is 1 over seconds. So you get meters over seconds, which means that your seconds cancel out. And when you take 340 and divide by 20, you should get 17. So I get 17 meters for that one. And go ahead and do the same thing over here. Wavelength is velocity over frequency. So 340 meters per second divided by 20,000 hertz this time. And if you do that, 340 divided by 20,000, you need to move the decimal over 3 times because we've added 3 zeros in the denominator, which means you need to move the decimal 3 times to the left. So I get 0.017 meters. So I want you to notice something here. I want you to notice that as, oops, sorry, getting a new color. Ask yourself the question, what happened when the frequency went up? What happened to the wavelength? The wavelength most decidedly went down. So commit that to memory. As the frequency goes up, the wavelength shortens. For this problem here, it talks about radio stations, and when you are tuning in your dial for your radio station, you're actually tuning it into a certain frequency. It's for FM stations, it is in megahertz. AM stations are in kilohertz, and mega means a million. So if you are at 93.1, that's 93.1 million hertz. And so I've put the conversion here for you so that you can see 93.1 megahertz is 93.1 times a million. We're going to leave that in scientific notation. And in the corner here, there's a little video showing you how to plug scientific notation into your calculator. So we're going to go ahead and solve for wavelength the same way that we just did before. Velocity over frequency. So we're going to plug that in as 3 times 10 to the 8th meters per second divided by 93.1 times 10 to the 6th hertz. And I'm going to plug that in for you. 3 exponent 8 divided by 93.1 with that little lowercase e to the 6th you'll see in the video. And you get 3.22 meters. Because when you have meters per second and you divide that by hertz, it cancels out, leaving you with just meters because hertz is 1 over seconds. Check out this video here if you need to know how to plug that into your calculator the right way. This problem gives you lots and lots of information, and you have to be really good about reading through and figuring out what it's saying. The first sentence says that a wave travels a distance of 15 meters in 1 minute. Well, if I'm telling you how far something went and how long it took, I'm asking you for the speed or the velocity of that wave. So remember that velocity is distance over time, and we want to keep all of our units in meters per second, not in meters per minute. So if I'm going to find this velocity, and I'm going to take distance over time, I'm going to take 15 meters over 60 seconds, not over 1 minute. So be careful with that. Make sure you convert from minutes to seconds. And when you do that, you get 0.25 meters per second. So that's the velocity of the wave. That's this part right here. The next part says something about passing a point, and there's a cork floating up and down in the water. So you can picture like a little cork sitting on top of this water wave, and it's moving down and it's moving up. And it bobs up and down 12 times in 15 seconds. So it has 12 cycles in 15 seconds. So what does that sound like? That is a frequency. So if we go ahead and divide and take 12 over 15 cycles per second, of course you're going to end up with hertz. You get 0.8 cycles per second. So that's this one. Now it says, what is the speed of the wave? We did that up here. That's 0.25. The next one says, what is the wavelength? So that's a little bit tricky. And what is the period? So the question actually never asks you for frequency, but you certainly need to know that to solve one of those two things. So to find my speed, I'm going to do frequency times wavelength. And to find my period, I'm going to do 1 over the frequency. So we can go ahead and rearrange and take our 0.25 meters per second divided by 0.8 hertz. So 0.25 divided by 0.8, 0.31. There's your wavelength. And your period is going to be 1 over 0.8 hertz. So I take 0.8, get the inverse, which is 1.25 seconds. So that one was a little bit tricky because it didn't give you the frequency. You just had to read the sentence and know that when it's telling you something's moving 12 times in 15 seconds, that's the frequency. And you had to, know that you had to use this part here in red to figure out the wavelength and to figure out the time period.